So starting early, the process overall is very collaborative because from the design side, it needs the support of consultants, structural engineers, contractors, and suppliers. So it's not something that we could just do as architects, at least, just by ourselves. We need to get input from the rest of stakeholders. In our workflow, we have a kind of palette of tools. Sometimes we start early with Athena, transition to Tally, where when we have a Revit model, and we could get a little bit more detail into a Revit-based LCA. But our studies are still general, and let's say we're comparing concrete to another material. And Tally also enforces our lead workflow for LCAs, and then we also use EC3 to get into product-specific data and optimizing product-specific data within a material. In terms of the workflow itself, we start with the Revit model, divided into the structural model, which we typically get a pretty accurate model from the structural engineers, and the enclosure model. And the workflow that I explained is a little lead oriented. So not sometimes we also do bay models early on, where we're just understanding a portion of the building or making decisions. So between enclosure and structure, the structural model, we would have a baseline and a proposed model, and we would do the same to enclosure, baseline and proposed, and then eventually link the two baseline models to create our lead baseline, or basically a whole building LCA baseline, and lead proposed models. So throughout this process, our goal is always to identify high impact materials. And, we already know that steel or any metals that go into the building are high impact. Insulation is high impact. Wood is high impact in terms of, its resourcing and how in its sourcing and how its positivity could shift depending on how you source it, and eventually concrete. Out of all of these, concrete being the second most widely material on the planet, only after water, and also being the third contributor to global warming potential after China and US, and we know how much we use it in our construction. We've really focused on concrete, and something that we've realized is that even in structures that are, sometimes we have buildings that are concrete structures, so concrete is a large portion of it, 50 to 70% of probably enclosure and structure impact. But even if we have a steel structure, we still have a lot of concrete. In a wood structure, we might still have concrete. So that material is just always there, and it's a large portion of the pie. Now the size of the pie might change depending on, if you have a wood structure, your overall impact might be lower, but concrete's always important to look into. The typical process is that we would get our concrete mix designs from the contractor structural engineer submittals, and we usually used to just approve them because they were structurally sound and they worked for the contractor. And sometimes we had maybe aesthetic qualities that we wanted to pursue. But now that we do whole building LCAs, we input these concrete mix designs into our whole building LCAs. And they often change because obviously the considerations with concrete go much beyond carbon, workability, cracking, schedule, all of these other issues that are very important. So these change, and we often have to rerun our whole building LCA model, and this was pretty time consuming. In some cases, one case was that we got an email from the contractor at 5 p.m. on a Friday saying that there were some issues with the concrete they were going to pour the day after, and that was a large portion of our mix designs, and they had to change it. So we had to kind of rerun our whole building LCA pretty fast. So we kind of realized that there's a gap for us, at least in the workflow, because the impact of concrete is so high, and sometimes we just need to make those decisions really quickly in a meeting, and we cannot really just ignore a change in a mix design. From our Tally studies, again, we knew that the impact of concrete is really high, as you guys see here in yellow. That's concrete in an example that I'm showing, and then going deeper into the Tally studies by ingredient, we see that in the case study that I'm showing, 46% of the impact of all the materials in structure and enclosure is literally from that cement in the concrete. So there's one ingredient that has a 46% impact. So from here, we kind of understood that, our optimizations really need to focus on cement quantity, but we also need to be able to do it fast, maybe decoupled from Revit. So this could be done without any knowledge of LCA by any member of the design team, the contractor, structural engineer, anyone could do it. So we created this simple, hopefully I'm not going too long, we created this simple concrete LCA tool that basically you select a region based on NRMCA data right now, having the 8 regions, and then you select a baseline 2016 or 2019 NRMCA baseline benchmarks. You select your concrete strength in terms of PSI, and then you just type the ingredients that you have in terms of pounds per cubic yard of concrete, and it will find a regional baseline for you for that strength. And based on data from Tally studies that we've done, and Tally kindly agreed that we could use this outside of Tally, it basically runs a quick LCA of that mix, compares it to the baseline. It'll tell you, it's better or worse in terms of the 6 impact categories. We've also added some functionality recently where you could compare a proposed mix to another mix that maybe you have better baselines that you're aware of versus an RMC, or maybe sometimes you're just making decisions between 2 mix designs. Let's say, you might need 1,000 cubic yards of 4,000 PSI mix for your for an application, but if you switch to 6,000 PSI, you might need 800 cubic yards. So it'll run the 2 and compare it. So it's in our workflow, this has been in line with our whole building LCA models, which we use Tally for. So the predictions are exactly what we get in Tally. And we've tested this. Eventually we run our whole building LCA, but it's just predicting what we would get for concrete. It doesn't require a Revit model, so it makes it all fast, doesn't require expertise in terms of LCA, and could be done kind of live real time, and it puts focus on cement content versus SCM. So we're not only talking about 15% SCM, where 15% SCM mixes might have very different impacts. The case study that I showed you was a building in California, and just by optimizing the concrete, we were able to reduce the amount of cement from the regional baselines by 4 million pounds. So 4 million pounds less cement, 21%, which was around 21% less cement content. So 15% less impact from concrete. And then after adding the enclosure, the whole building was able to reduce its impact by 10%. So after being able to just do this on many projects at ZGF and being able to really optimize concrete and reduce the impact of that building by 10 or 15%, we also, again, thanks to Tally, thanks to NRMCA, everyone agreeing with this, we made it public for free. So now we got around 250 people using this in academia, contractors, architects, to optimize their concrete. And you could send an email to lca-tool@zgf.com if you're interested to get a copy. Thank you.
Thank you very much. So we have a few prepared questions that I'll be asking, and I want to encourage people. I think it looks like the Q&A button at the bottom of your screen is the best way to submit questions that you might have for the speakers. So I'll start off with, we talked a little bit about how these things can be used at various stages of design, but I have to say that for me personally, the whole idea of a baseline model,
yeah,
a little bit mysterious. How do we establish that baseline? Stacy talked a little bit about it, that it's accounted for in EC3, but how do I figure out what percentage better I'm doing than?
Yeah, and it was just as good, if not better, when we did the practice.
Chris, you're on. Let's start with Roderick.
Sure, absolutely. So the issue of baseline is an interesting one, because a baseline essentially isn't, it shouldn't be necessarily, it's not a performance achievement in the sense, it's just like a normative practice. And so that you're trying to compare yourself to. So you're always trying to do better than baseline, as opposed to, say, a benchmark, which would be like sort of a high level performance you're trying to achieve. The way that the industry works right now is that your baseline is always self-referential. You create your own baseline, and then you compare your actual design against that baseline. The guidance for creating that baseline, I'd say, is probably largely centered around the methodology that LEED proposes, which is essentially that you have a building that is an equivalent functional unit, which means that it's the same size, it performs the same function, and it has the same energy performance. And that is sort of the very general sense of what would constitute the baseline. What we provide more guidance and more detail on that LEED guide that I showed briefly during my presentation. But as part of that, there's several ways to go about creating that baseline. The simplest way that we see most people do it is they design as they normally would. And then just like I was saying, that they are always making material selection decisions to optimize performance amongst other considerations. Essentially, your baseline becomes all those decisions you didn't make. And all of those sort of unfortunate materials that you left by the wayside that you didn't choose for your actual design. And that's typically what we see. It takes a certain amount of accounting. You want to keep track of all of your LCAs that you've done throughout your design, probably a little bit of Excel addition and whatnot. But that's typically the methodology that we would recommend. I think in some cases, you'll find that just swapping concrete gets you the better performance that you need relative to baseline. But on some of our projects, we found ourselves chasing 0.1% of improvement in performance. And at that point, you're getting incredibly detailed on the level data. You're looking at coatings on your curtain wall and things like that. But just to add on before I cede the floor, one of the things that we're excited about when it comes to understanding the performance is more that external verification. How do you compare to other people? And we're really happy to know that the AIA, with their DDX exchange for everyone that's part of the 2030 challenge, or the signatories there, is that they are going to start including embodied carbon in October. And we've worked with them to understand their methodology by which now Tally customers at that same time in October will be able to upload their Tally assessment to the DDX so that they can get a comparison, at least a carbon, of their building versus what other people are doing within the same material category that have done Tally runs. And they'll also have the ability to compare the outputs from other tools as well. So hopefully at that point, we can start moving from sort of a self-referential baseline to a baseline that's tagged to actual buildings out there in the real world.
Thank you. Baha, this question that comes to mind for you, and maybe you covered it in your presentation, I didn't catch it. As an architect, I don't feel like I'm an expert on concrete mix design. And so when I think about putting a stake in the sand about where the mix design ought to be, I would have to turn to my structural engineer and say, what do you think? So how do you, as an architect, engage with that mix design transition?
Mm-hmm. And I gotta say, we've also really focused on concrete, but at the end of the day, we're not experts on concrete either. And that's why I said the process is really collaborative. Something that we've tried to do in the last year or so is that at least through the concrete LCA tool, to make the process so simple. And we've kind of defined a workflow of starting with starting the discussion with some sort of a baseline, which we use in our MCA baselines at the moment for, and it could also be the CLF baselines. So sometimes we start with providing the table of different strength mix designs and how much cement literally we have in each mix. And we ask the contractor and the structural engineer to not have mixes if possible, considering all the other issues that have more cement. So really focusing on the cement content. And that starting that discussion kind of sometimes create this workflow for them that they don't go out of. So we've seen a lot of success. Sometimes literally just talking to people would have a lot of impact. And then, there's always simple tools that you could use. You don't really need to have a knowledge of, LCA. Obviously, we cannot design the mix, so it has to go through the structural engineer. But let's say if you could share the concrete LCA tool with your structural engineer, and they could do the LCAs and just keep you posted, that could be really optimized.
That's a great idea. And Stacy, your take on baselines?
Well, I think I have a whole presentation on baselines versus benchmarks and what's happening around that. And it's based on the book Shark versus Train that my son used to read. You know, Shark versus Train, who will win? Baselines versus benchmarks, who will win? They each have their place, and some are better if, you know, you're in the ocean or if you're on land. But I think the important part is that we are trying to create metrics because psychologically we all want to show reductions against something. And it's right now it's okay, I think, if there are multiple baselines, if you're just choosing one and you're referencing it to show a reduction. I think future state should be that we're all talking about how far above zero we are. Because zero is the same for everybody. So if we can get to a place where we're really just doing that measurement and saying, okay, you know, we're this close to zero, I think that's really the target we're all shooting for. But right now, you know, we've got our baselines that we're using that the Carbon Leadership Forum has established that are material category specific, which is really based on supply chain data and what the numbers are when you're choosing particular products or manufacturers. You know, whole building LCA is using kind of average data to get to benchmarks or baselines. And I think I guess my status is just start with one and try to show reductions and let the industry kind of work towards alignment. Because I think we are getting closer now that we're all talking about it and disclosing what we're doing.
Mm-hmm.
Stacey, I would just chime in to go one step beyond and say not how close to zero, but actually how much below zero we're
Eventually,
getting.
that's where we should be, right?
I think that's where we're going to be. I think
Yeah.
buildings are going to be carbon sinks. I'm planting a flag in the sand on that one.
I'll plant mine with you.
Well, my next question is, I know that this topic for myself, when I first started digging into it, and I'm a novice by comparison to you folks, it's just daunting. It's a huge amount of information that none of us studied in school because it's an emerging science, if you will. And we have a lot of practitioners out there that they're understanding that embodied carbon is a really important thing and that they've got to deal with it, but they don't know where to start. So my question to each of you is, what is that essential first step, that thing that you can do that means that you can actually implement something right away, the first step? Roderick, do you want to take that first?
Sure. And I'll actually just come to it. I'm coming to it from a commercial software perspective. So what has gotten people to actually use Tally? You know, we always had a lot of people downloading it, but not always really getting deeply into the trial. And what we found was that providing the Revit, the advanced Revit model pre-populated with Tally data, it's the same one that we use in all of our webinars, the same one that comes with everyone's copy of Revit. Having that with Tally data in it allowed for someone to just open it up, launch Tally, and instantly see the impact of various materials. They can run a report right there, and they can see how much insulation contributes. They can change the insulation and see what the difference is. And it was really that small little switch for a lot of people instantly demystified it, because they realize that all it is a formula of how much stuff, impact of said stuff equals your life cycle assessment. And once they're able to see those pieces together, they realize it's actually it's quite easy. And so for us, that was the catalyst to get people to jump in.
I'll start with the software perspective first. I think, you know, the way EC3 came to be was me as someone in construction trying to wrap my head around how to use environmental product declarations to compare manufacturers and products, and having to read through multi-page PDFs and create my own spreadsheets around these global warming potential numbers that I didn't really understand how they came to be. I just had to find them on page 22 and put them in an Excel document. So EC3 is there to try to make that part easier, where it's 2 or 3 clicks to get to a comparison of products for a material category. So I would just plug to please just start using EC3 to help you understand at the product level what your options are for the materials we include, and we continue to expand that. I also think that, you know, ZGF's approach, just pick something and get really good at understanding it. If we all pick something and they're different things, then everything moves forward. So it's okay if you don't do everything at once. Maybe just pick one project to try Tally on. That's still one project that you're getting smart on that you can apply to the next one. Maybe just pick concrete, or if you're an interior designer, just pick carpet or gypsum board. But if we all just pick something and really dig into it and not get overwhelmed by the total kind of happens. So I think that's my advice, is just start. Don't feel like you have to start on everything, but pick a place to start and really commit to it.
I think Stacy and Rod really covered it really well. I'd say in our workflow, something that's been pretty successful has been to really simplify and only look at high impact materials when you're getting started. And when we get more detailed, it's just really easy to get stuck on a tiny piece of the large pie and try to optimize a material that might be 0.005% of your total impact and show 70% reductions. But it's just look at the larger picture, look at the high impact materials, which you could just look at a lot of studies. The model that Rod is mentioning, you probably see the structure, insulation, metals. So look at those and try to optimize them. As we get better over time, hopefully the materials also get better, and then we could really fine tune our process.
Sharon, you're on mute.
I see it as a two-part approach here. I think it's really important to do, as Baha says, that we need to go after those high impact materials right away. But I also see this as the moment in the life cycle analysis that in a way parallels where we were with FSC wood a little over 20 years ago. And that is a place where it's so critical that we reach out to manufacturers, architects, and designers, and we say, we need your EPD. This is important to us. We're measuring selections by the EPD. And we did that with FSC for a long time, and we so often got people saying, we don't know what FSC is. And eventually that changed, and we moved the marketplace as a profession. And we need to do the same thing with EPDs. And I'm encouraged to see that EC3 provides sort of that sample template. Stacy, maybe you could go over that again. I think it's a really important piece of
Yeah,
it.
if you go to buildingtransparency.org, we have a resources downloads tab where you can access those templates. And, I just heard today that there's a certification program that's building in a point for just sending that template out to manufacturers here in Washington. But we've seen success. If you download it, it's project specific. You can template it to whatever material you're talking about. On some of our projects where we're using that and even providing the bid language, we've got 3 or 4 suppliers investing in EPDs because we've asked them. So again, if we're all starting with that one step, similar to other things like VOC content too. When I was just starting out and I had to call people and ask them for VOC content or anything else, now it's just published everywhere and it's kind of commonplace. So I think, yes, I agree 100%, Sharon, and we're already seeing that work. We just need to do it really quickly because we don't have a lot of time to get to zero carbon.
Speaking of carbon solutions, existing buildings, tell us about Tally and existing buildings.
So this is something that we've been on for a little while. Tally does a pretty simple approach that aligns with what LEED requires as well in their methodology, but one in which if you mark every material that you've specified in Tally has the option of marking as salvage or reused. And when you do that, it removes what's referred to as the module A impacts, which are actually the impacts that you would find in EC3. It's the manufacturing impacts. But what it doesn't take away is the impacts associated with maintenance and replacement. So, your paint's still going to have to be replaced and things like that, obviously. And it also doesn't take away the end of life impacts associated with that material as well. There's always some question about methodology. There's actually a paper on that. If anyone's interested, they can always hit me up later and I can send them a copy that we wrote that was in Building Energy about different life cycle assessment methodologies. But from our perspective, that methodology that's used by LEED and then also reflected in Tally workflow is one that's probably the most logical and easy to understand for the end user. But it makes a huge difference as far as impact. There's frankly nothing you can do that's going to be equivalent to reusing a building. We see usually 75% decrease in global warming potential for reuse, particularly of the big stuff, the structure and whatnot. But I mean, that's massive. And it's really, it's a challenge though for us as both designers and the users or creators of Tally is that we have seen with our analysis that the buildings that get reused most frequently are those that are vastly overbuilt. These are the ones with thick floors that you can really cut into that are sufficiently robust to maybe withstand a period of time in which they're not used, things like that. Whereas the buildings that were optimized or could have been considered to be optimized for global warming or life cycle performance are ones that are typically lighter weight they're not as robust, and sometimes not as adaptable. So there's a little bit of a challenge, I think we find, of essentially balancing those two things. You know, it's great if you reuse it, but you don't want to overbuild it if you're not going to reuse it. So it's a little something that I think that it keeps in the back of our minds when we look at all the projects we reuse. And we want to think, well, geez, will someone be able to reuse this building that we just designed and built that's incredibly lightweight and material optimized?
Mm-hmm.
Can I add on to that just a little bit, Sharon? Because I think right now, with what's happening with COVID, I think there's going to be a whole bunch of buildings that are not going to be used the way they have been in the past, specifically commercial office buildings. And I think us as practitioners bringing to clients that might be thinking of tearing those buildings down or not being able to kind of adapt them to other uses, to bring to attention this embodied carbon impact of those choices is going to be more important, perhaps. You know, REI just built a whole campus here in Washington, and they announced yesterday they're selling it before occupying it because all their employees are going to be working from home. And the thought that they just built this entire campus that is now sitting empty, I think there's going to be a lot of that. So this reuse question and not tearing down things that are existing is going to become, I think, even more prevalent. So I think it's on all of us to be able to show those reductions and those potential changes of impact based on our choices.
Mm-hmm. Well, we're getting close to the end. I want to make sure I get to the questions that are in the question box. One of them is, would you please explain if baseline models are different models? If they are different, how are they set up different? If they are the same, how are they set up to integrate best with the rest of the BIM info from the project? I think this is about, are they two different models or are they one model?
Maybe I'll just briefly touch on that. In our workflow, basically, if we are doing optimizations in the baseline that are, at least for lead, I would say if it's really meaningful and it's worth making changes. With structure, optimizations are a little easier, especially with concrete. You're not changing the volumes you're not changing the design. You're changing the ingredients. So you could use the same model, change the ingredients, and you have your baseline and propose. With enclosure, things could be a lot more complex if you are changing your design. Now in enclosure, you also have materials where you could change the ingredients and it might be the same mullion, maybe the finish changes or something. So those are easy, but if they're difficult, we typically keep our baseline and propose the same. And we still do all the optimizations in the design process. We just don't go back to make a baseline because it's just might not be worth it in terms of time. If we're really fighting for lead for 0.5% or something, we might do those changes. And we also always try to be very conservative. So we never go back and pretend that the baseline was worse than what we were just gonna do. So that's, I think, is also important. So we don't just show percentages that are not meaningful by creating a baseline that's worse than what we were actually going to do as proposed.
Right.
So hope that answers it a little bit.
Okay. This person, without getting into too much detail, if that's possible, how does Tally appear in Revit? Does it begin tallying in real time as you create the model? There's a second question after that, but I'll let you take that one first.
Sure, it's pretty easy. It just shows up in the add-ins tab. So it's a Revit application in that sense that you can download it from the Revit App Store, or you can download it from us, but it'll show up in your add-ins tab. And how it does is when it's first launched, it'll essentially read the materials all the parameters associated with the materials that you have in your model, and provide an initial material takeoff that you then modify and make more accurate through the Tally interface. Essentially, if you want to rerun that initial review of the Tally materials that Tally creates, you just refresh within the interface. It'll reread your model. And that'll work well if you have, say, a team that's using Tally, multiple people at the same time on a cloud-hosted model. So if someone makes a change, you can refresh, and that data will be in there. So that's essentially how it works. It'll save out a report on demand. So it's not as if it'll run out of sort of a constant. It's not like a speedometer, if you will, or something like that of your global warming impact. You do have to save out a report. But the part of that is just so that the report itself is compliant with the International Standard Organization's requirements for an LCA report.
Well, you've answered the second question, which is whether or not it's possible to get rough takeoffs for life cycle analysis as you go along, and it sounds like that is absolutely the case.
It is, and you can get takeoffs both in quantity and in impact as well. So when we output an Excel report, it's all a series of pivot tables that are pre-formatted, but for those that want to go in, they can select any category from the pivot table and review actual material quantities, kilograms of materials, things like that, really get down to the nitty gritty. I mean, some people love diving into the detail, and some people probably shouldn't be diving into the detail as far as I can tell from the customer support perspective, but that's all right.
So we just have a few minutes left here, and I'd just like to ask each of you what your most important message is to the practicing community. What is that message about the work that you do and the importance of it? Stacy, we'll start with you.
I think it's just we have a tendency to wait for perfection and we don't have time. So I think it's back to my previous point of just start with something and don't be worried about if it's going to be exactly right. When it comes to embodied carbon, I think that the 3 tools you have represented here today are, if you used all 3 of them, we would be at a really good place. So just you start with one of them. But I think, I'm really excited about the uptick in folks looking at whole building LCA through Tally, the ability to look at concrete specifically, and then the ability to have open access EPD databases. So just start using the tools that we've showed you today, and don't be afraid of not everything being in perfect alignment right now. We'll get there.
I'd say my message is just very similar to Stacy's. Start with high impact materials, try to make them better. Something we're trying to do at ZGF is that we're aiming to optimize a structure, concrete mainly. Sorry, I keep talking about concrete, on all of our projects through a little Excel spreadsheet, and document that impact in our 2030 document. So optimizing whatever 50 projects by 10% or 15% versus one project by 20% or so, and yeah.
Thank you. Roderick?
I would say to people that are thinking about this, first of all, that the impacts of the materials that you are putting into your buildings are happening whether or not you're running an LCA. And those impacts are significant. And the second part to that is that once you have quantified those impacts, you will find that picking better materials and systems that dramatically lower that impact will have absolutely no other differences when it comes to cost, buildability, aesthetics. All those things will be exactly aligned. It'll just be a heck of a lot better environmentally speaking. So essentially, it's an absolute zero cost way of doing good. And it's that easy.
Okay. Well, I have to thank our panelists. I have one question that ended up in the chat, but I will email it to all of you so that you can talk together, because it's a good question about incentives for contractors, but we don't have any more time. This has been a fantastic panel. I feel like we need to have you guys back again in the future to talk about this. You've been tremendous. Thank you for your time and the work that you do. Thank you.
Thanks.
Thank you for having us.
Thank you.